Tuesday, we're gonna learn about target encoding, hip hip hooray. Tuesday, we're gonna do a StatQuest live stream today. Hooray! I'm Josh Starmer and welcome to the StatQuest live stream. Again, I need to put this very carefully on the floor, and it looks like one of my cats just came in the room. If you just saw that, Poe is walking through. Anyways, hello, Poe. Today we're going to talk about target encoding. We're going to do a lot of cool stuff, and then we have lots of time for questions at the end. So, without further ado, let's move on to talk about target encoding. And actually, we're not just going to talk about target encoding. What we're actually going to talk about is one-hot-encoding, label encoding, and then target encoding. So, bam! Okay, imagine we had this data and we wanted to use favorite color and height to predict if someone loves Troll 2, which is a really terrible movie that I know I've talked about for years, but I only just recently watched a few months ago, and it was as bad as everyone said it is. But some people love that movie, so let's go for it. In this case, favorite color has 3 discrete values: blue, red, and green. Now, in theory, discrete features like favorite color are fine for most machine learning algorithms. But in practice, a lot of popular machine learning algorithms, including neural networks, do not work well with them. As a result, discrete data are often converted into numerical values before being used for machine learning. One popular method for converting discrete variables or features into numbers is to use something called one-hot-encoding. When we have 3 or more options for a discrete variable, and in this case, that variable is called favorite color, we have 3 options. So we start by creating a new column for each option. In this case, that means creating 3 new columns: blue, red, and green. Now, in the blue column, we set the value to 1 if we had blue in the original favorite color column. The favorite color column. That's almost a tongue twister. And we set the remaining values to 0. Likewise, for the red column, we set the value to 1 the one time we had red in the original favorite color column. So we only had one instance of red, so that one value gets set to 1, and the remaining values are set to 0. Lastly, for the green column, we set the value to 1 if we had green in the original favorite color column, and we set the remaining values to 0. Note, the last column, loves Troll 2, is also discrete, but it only has 2 options, yes and no. So we can simply replace yes with 1 and no with 0. And now we have all of the columns in our new data set are numeric and can be used with algorithms that don't do well with discrete data, like neural networks. Bam! Using one-hot-encoding to convert discrete data into numeric data works fine when we don't have too many options. In this case, we have 3 options for favorite color. So we replace favorite color with 3 new columns. But when we have a lot of options, for example, if we had a column of postal codes And there are 41,683 postal codes in the United States. I just Googled that yesterday, by the way, so I think that's pretty accurate right now, today. Anyways, then we would end up replacing the one postal code column with 41,683 new columns, which might make the data difficult to work with. It would make it difficult to open up in Excel, that's for sure. Anyways, so when we have tons of options for a discrete variable, one alternative to one-hot encoding is to simply assign numbers from low to high to each option. So in this case, we might set blue to 0, boop, and red to 1, boop, and green to 2, beep. And just like before, we could convert loves troll 2 to be numeric by setting yes to 1, beep, and no to 0, boop. Again, just like before, all of the columns are now numeric, and we can run the data through a neural network. Double bam! Note, one thing people don't like about using this approach, which is called label encoding, is that the numbers we use are just arbitrary. And some machine learning algorithms will treat the order of the numbers as if they might mean something, and that can cause problems. So instead of just picking random numbers to represent the options blue, red, and green, we can calculate the mean value of the target, the thing we want to predict, which in this case is loves troll 2 for each option. For example, of the 3 people that like the color blue, only one of them loves troll 2. So the mean value for blue is 1 divided by 3, or 0.33. So we replace blue with 0.33. Beep. Likewise, because only one person likes red and they do not love troll 2, the mean for red is 0. So we replace red with 0. Boop. Lastly, because 2 of 3 people who like green also love troll 2, we replace green with 0.67. Boop. Because we use the target, the thing we want to predict, to determine what values to replace the discrete options, this method is called Target Encoding. That being said, we've only talked about the simplest type of target encoding. A more commonly used version of target encoding deals with the fact that we only had one person who liked the color red. And that means we only used one person to determine the mean value for red. And thus, we don't have a lot of data supporting the use of 0 to replace red. In contrast, both blue and green have more data, 3 people each, supporting the values we use to replace them. Because less data supports the value we replaced red with, we have less confidence that we replaced red with the best value than we have for blue and green. So, in order to deal with this, target encoding is usually done using a weighted mean that combines the mean for a specific option, like red, with the overall mean of the target, which is loves troll 2. So let's look at the equation. Bam, there's the equation. It looks very fancy, but it's really just a weighted mean of the option, the overall mean, the option mean and the overall mean. So let's look at it in action. It's a lot easier to understand when you see it in action. So for example, in order to use the fancier target encoding with our data, we start by plugging the mean of the target for blue, 1 divided by 3. We plug that in. Then, because 3 people were used to calculate the mean for blue, we plug in 3 for n. So that's the weight for that mean is 3. Boop. Then we plug in the overall mean for the target, which is Love's Troll 2. And that's 3 divided by 7, because overall, 3 of the 7 people in the entire data set love Troll 2. So we plug in 3 divided by 7. Now we just need to pick a value for m, the weight for the overall mean. M is a user-defined parameter, or hyperparameter, and in this example, we'll set m equal to 2. Boop, boop. Setting m equals to 2 means we need at least 3 rows of data before the option mean, the mean we calculated for blue, becomes more important than the overall mean. And specifically, because I knew that blue had 3 rows of data supporting it, both blue and green have 3 rows each. That's why I set m equals to 2, is to sort of like, in those cases, the overall, the mean that we calculate for blue, the option mean, is going to have a little bit more weight than the overall mean. If you have a larger data set, it's worth looking at the frequencies of the different term to decide what the best value for m is. Some people use m equals 300, meaning you need at least 300 rows of data before the option mean becomes more important than the overall mean. So it really depends on your data set. So just take a peek inside and maybe plot a histogram or something of the different terms in the categorical variable to decide what a good value for m is. Okay, now we just do the math and we get 0.37. So we plug in 0.37 in for blue. Beep. And now we calculate the weighted mean for red. So we plug in, we've only got one observation or one row of data, so n equals 1. That's the weight for the option mean. And then we plug in the option mean for red, which is 0 divided by 1, because the one person who likes the color red does not love Troll 2. Then we plug in the weight for the overall mean, which is user-defined, which we defined previously to be 2. So we do that, boop, boop. And then we plug in the overall mean, which we already calculated was 3 divided by 7. And then when we do the math, we get 0.29. So we plug that in. We plug 0.29 in for red. Boop. Lastly, we calculate the weighted mean for green. Beep, boop, beep, boop, beep, boop, 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 beep, boop, beep, boop, boop. And we get 0.57. So we plug in 0.57 for green. Now let's compare the target encoding when we use the weighted mean to the target encoding without the weighted mean. So this is the original target coding we did, which only relies on the option mean for each value. The target encoding for blue and green are similar to what they were before. They're not the same, but they're similar. And this makes sense because we had a relatively large amount of data for both blue and green. In contrast, with the weighted mean, the value for red is much closer to the overall mean than before. So we went from the value for red being 0 to now it's 0.29. So it's relatively speaking much larger than it was before. And this also makes sense because we have so little data for red, only one row. In a way, we can think of the overall mean as our best guess given no data. However, as we get more data, and that means we get more rows for each option, we use the data more rather than our best guess to determine the target encoding value. Note, if you're familiar with Bayesian methods, this approach may look familiar because most Bayesian methods boil down to calculating a weighted average between a guess and the data. And Usually with very little data, the guess gets, has the most weight. And as you add data and you increase your data set size, the data becomes more important to determining the output. So that's kind of sort of like Bayesian methods in a nutshell right there. As a result, some people call this a Bayesian mean encoding. Triple bam. Note, some of you may have noticed that by using the target, the thing we want to predict, to modify the values for favorite color, and doing this sort of, some of you may have noticed that this is what we're doing. And doing this sort of thing is a data science no-no that we call data leakage. Data leakage results in models that work great with training data, but not so well with testing data. In other words, data leakage results in models that are overfit. The good news is that there are a bunch of relatively simple ways to avoid data leakage, or at least reduce the amount of data leakage, so that you can use target encoding without overfitting your model. And we'll talk about those methods in the future, quite possibly in the AMA that's just about to come up. Bam! All right, so now we've made it to the AMA portion of the live stream. So we're going to go back, switch camera angles, and we're going to look at the holy smokes. I just noticed that Ash U2 just made a donation. I guess that's a super chat. That's the technical term for that. So I'll give a shout out to Ash U2. Thank you very much. And I also want to say hello and thank you to Imad Ramuni for being a channel member. That's awesome. So let's scroll back and see if we got any questions. And we do that to add meaning to the order of the encoding. So I don't remember the context of that, but I'm guessing when they're talking about target encoding, yes, the encoding gets some meaning. What else we got? Any other questions down here? John Lee asks, does the encoding method have any requirement on the independency of different columns? That's a good question. So one thing target encoding can do is if there is a nonlinear relationship between the variable. I believe this is correct. The variable event, the discrete variable. So say like we're talking about favorite color. If there's a nonlinear relationship between that and and the target, which is Love's Troll 2, I think there can be some funkiness going on. I'm not exactly certain on this one, and it makes me want to look into it more. I think there can be, and I think this is a situation where one-hot encoding may work better. That being said, one-hot encoding, so I think one-hot encoding is sort of like, generally speaking, for most machine learning algorithms, the way you want to go, unless you've got tons and tons of options for postal codes or something like that, and then it's just a nightmare. By the way, this is part of how cat boost works. I don't know if you're familiar with that. It's a boosting method. It's a lot like XGBoost, but it adds a type of feature encoding. In cat boost they call it ordered target statistics. I guess I meant to say it's a type of target encoding. Anyways, they call it ordered target statistics, but it's a very similar technique. And basically that ordered part of what they call it is their trick for reducing data leakage. They make a big deal about how their methodology eliminates all data leakage, whether or not that's super important or whether or not you just need to reduce the data leakage. That's subject to debate. But they think they've gotten rid of all of it, And that's something I want to talk about possibly in my next live stream. Part of it, I'll be honest, I'm just going to tell you this. A lot of people have been asking me about Cat Boost, and so part of this live stream over the next couple of weeks or months actually is going to be running through all the little details of how Cat Boost works, and then hopefully I'll be able to put this together into a single video on Cat Boost. So that's sort of the master plan here. So we'll just kind of run through all the little bits of how Cat Boost works. All right. Yeah, so to get back to Lynn's question, I said some algorithms assume meaning of the encoding order if we just encode it with red equals 1, blue equals 2. Yeah, some algorithms will think that's some sort of like ordering, and the ordering is significant, and that red is somehow, less than blue, or, like imagine you had a pain scale on from 0 to 5. How that's related. It may sort of come up with some way of implying that the order is important, and that can cause problems. Someone just asked, what's the difference between one-hot encoding and label encoding? One-hot encoding, remember we replace the columns, the column of interest, with individual columns, one for each option, and we have zeros and ones in each column. And for label encoding, we use the exact same column, and we just replace the options with numbers, usually from 0 to some high number representing the total number of options. So someone says, do we have, someone asked if we have a long short-term memory video incoming. And the good news is yes, 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 yes. So some great news is about 2 weeks ago, I had a major breakthrough with the exam. So one of the things about StatQuest, you may have noticed, is I like to use very simple examples. I want them to be complicated enough to illustrate the concepts, but no more complicated than they need to be. And so for the long short-term memory videos that I'm coming out with soon, one of the key items was to come up with a data set that was easy to visualize, but illustrated sort of how awesome long short-term memory networks are. And I had a major breakthrough about 2 weeks ago where I created by hand the whole long short-term memory sort of neural network stuff, and it worked great. And then I spent the next week trying to get it to work in PyTorch. And I succeeded. My friend Adrian, he helped me again. That guy's awesome. He's one of my coworkers at Lightning. And anyways, he helped me out with that. Anyways, once we got those out of the way and I see that the example works in multiple contexts, it's solid. It's just a matter of me. I've got the graphics in place. It's just a matter of me scripting it. And I think that will take probably either in a perfect world, I'd have it done by the end of the week, but I really think it'll probably be the end of next week, because things always take longer than I expect. If there's one thing I've learned from the journey of StatQuest, it's that things take forever. But anyways, so yeah, long short-term memory networks, hopefully at the most 2 weeks from now. We're going to do 3 videos for that one. We're going to do, actually, no. We're going to do 2 videos for that one. We're going to do one, which is just all theory, and you'll see my simple example, and we'll see the math, and we'll do it by hand, and we'll see how it all works. And then we're going to do another video of how to do it in PyTorch, and that'll come with an accompanying Jupyter notebook that will be free and you can have. So that's something I'm really excited about. So that's the update on long short-term memory. Someone asked if we have some methods to test if there's a significant nonlinearity between some categorical variable and a numeric one. That is a good question. To be honest, it's kind of weird. I feel like I've got to backtrack a little bit, and this is also revealing sort of a weakness in my knowledge. So, so you know, the more I talk about it and say it during this live stream, the more I'm like, how could you possibly detect a nonlinearity? Because it's like it's in bins. It's in very, each discrete option is basically its own bin. So how can we detect that? I do not know. And how could that even be a problem? Again, I do not know. It doesn't make sense to me. But maybe when we do the label encode or the target encoding, excuse me, when we do the target, that introduces a potential linear relationship. And maybe that's the problem. It's not that the discrete values have a linear or nonlinear relationship. Maybe it's that once we encode it, we establish some sort of relationship. And if it's nonlinear, then that's a problem. And one way we can do that to test that is we can just plot it. Bam. X-axis, our new labels. Y-axis, our target values. So that's something we could do there. So someone asked if I plan on doing a video on the difference between cat boost, light GBM, and XGBoost, and ultimately the answer is yes. Once we get through doing cat boost, we'll start talking about light GBM, and once we have all three of those things, because we already have videos on XGBoost, it does make sense to have like a short recap of the differences. I can tell you sort of off the top of my head, this is right here is one of the big differences. I don't know if you remember from XGBoost basically uses one-hot encoding, but what it does in order to keep from crashing with all the extra columns it creates is it uses something called sparse matrices. And what a sparse matrix is a matrix where you only care about the non-zero values. So when you do one-hot encoding, you're going to have lots of zeros. Most of your data set is going to be zeros. And basically what XGBoost does is said, I'm just going to ignore the zeros and only remember where the ones are. And so it uses what's called there's a sparse matrix. It uses a sparse matrix, and a sparse matrix is just a matrix that ignores where the zeros are. In contrast, cat boost uses a flavor of target encoding. And we'll talk about what light GBM does too. It uses a histogram approach. So we'll do that one of these days. Someone says they want a tip on where to start. They want to create a neural network for answering basic questions based on answers to similar questions, but I have very little experience with such things. Any tip on where to start? I'll be honest. I'm going to be totally honest with you. I've got very little experience with that as well. However, it's funny that you mentioned this because I have a friend who just came up with a sort of a natural language sort of preprocessor, potentially for neural networks. But what it does is it takes two sentences and it compares to see how similar they are. He just released this code on GitHub. I wish I could remember. It's like Simplifile, the love of simplicity. I think that's the name of it. You can check it out on GitHub. Actually, I might be able to paste it into the chat. Let me see if I can do this. Yeah, so I'm sharing with you. This is my friend Brian Risk. I've known him since we were in high school together, and we've been in bands together, and we go jogging together. And he cooks delicious meals for me on Thursday nights. Anyways, he's a good buddy of mine. Oh, by the way, he's hiring. Anyway, so he's got this library for comparing sentences. And so if you're really interested in coming up with a way to answer questions that are similar to other questions, well, this library might give you a good way, an easy way to answer that first question of, is this question similar to another question? So that'd be a great place to start. So check that out and maybe get a job for this guy. I mean, he's an awesome dude. He's my buddy. Um, yeah, I've known him forever, and yeah, he's my man. So check out Brian Risk's thing on GitHub called Simplifile, the love of simplicity. Okay, someone asked if I prefer PyTorch or TensorFlow, and this is embarrassing. Um, I've only used PyTorch. The reason why I like PyTorch so much is I work for a company called Lightning that creates something called PyTorch Lightning. And I'm going to be honest, I actually genuinely love PyTorch Lightning. Um, it solves a lot of problems. So when I started doing my neural networks videos, actually, you might want to, why am I working for Lightning? Why would I take a job at this company? Anyway, so when I started making these videos on neural networks a couple of years ago, I was like, oh, this is fun and we're learning the theory. But I had this vision in my head that something that would be super cool would be to not just talk about the theory, but to also show how to actually deploy a real production grade neural network trained in the cloud, operates in the cloud, you know, because I feel like, you know, obviously theory is cool, but when you're working in your job, theory doesn't always help. What you really need is the applied, like this is how it actually is done. And I didn't like the idea that StatQuest was kind of useful for theory, but not really useful for work. And I was like, you know what I want to do for neural networks is show how, you know, we'll start small and we'll start simple, but I want to build up to where we're doing production grade stuff in the cloud. And I was like, yeah, but using the cloud is kind of a pain in the butt. Using PyTorch also is. And and I was just like, ugh, you know, because I want to do this, but and I want to make it real, but I also want it to make it as simple as possible. That's like the StatQuest, you know, goal, right? I want things. I like to make things simply explained. You know, it can be complex, but I want it to be simply and clearly explained. That's my goal. And what it turns out is with PyTorch Lightning and Lightning.ai, they want complicated things to be easy to do. And it just so happened that I wanted to make a neural network and they wanted the same thing. And so I was like, well, we got to do this together. And it's actually been a great, I hate to use the word synergy, because it's been my goal for years, and they're like, we just want to help you achieve that goal. And it's been great because working for them gives me access to some of the best PyTorch coders in the whole world. So when they help me and we create these Jupyter notebooks, it's not just sort of like my opinion. I get experts on neural networks, people that have done this in industry, people that have trained like crazy neural networks for CNN. I know, you know, one of my coworkers at CNN. Others, you know, one of them like creates AIs for games. You know, this is like people doing real stuff that are helping me create these awesome Jupyter notebooks. And so so that's the goal. So the dream is like StatQuest will be cool for the theory, but also you're like, oh, I can do this at work too. So that's what's going on there. What else do we got? Yeah, so I don't even remember what the question was anymore. I hope I answered it. Um, and let's see if we got any other questions on here. Oh, yeah, someone was asking me about TensorFlow versus PyTorch. And the answer is I've actually never coded in TensorFlow. Although my good friend Sebastian Roschke, who, by the way, also works with me at Lightning, which is super cool. I don't know if you've seen his stuff. He's super active on Twitter, and he has a great website that has all kinds of cool stuff. And he also wrote this awesome book. Hold on, I'm going to go get his book. I'll be back. My friend Sebastian wrote this book called Machine Learning with PyTorch and Scikit-learn. It's pretty popular. Anyways, he's working at the company now too, which is cool. And he said he used to code in TensorFlow, and he was like, I don't like it as much as PyTorch. So he's an expert. I refer to him as the person to talk to about these things. So what else do we got? Any other questions? Oh, any idea when you'll be dropping the Transformer video? Yeah, so maybe by the end of the year. um, I, I, I think if we get long short-term memory videos out in this month sometime, hopefully in 2 weeks, immediately I'll start working on attention, and we'll probably have a video on attention, and then a video on Transformers. So possibly by the end of the year. There's a sort of a lot to do between now and then. Holy smokes, we've got a lot of Chinese, looks like, in the chat. I don't actually know Chinese that well, so let me translate some of this to see what's going on. Ah, they're saying nice things about me. So that's nice to hear. Anyways, what else do we have? Oh, someone sees the Indian instruments. Yeah, so yeah. Actually, someone asked this last time. I forget that I'm surrounded in musical instruments. Obviously, I love my ukulele, or ukulele, if you're going to pronounce it correctly. I grew up saying ukulele. But I think in Hawaii they say ukulele. And anyways, I love this instrument so much, but I'm surrounded by all these awesome instruments, including tabla. I've got another Indian instrument over there that you can't see, which is awesome, but probably way out of tune. I've also got I also play the cello over here. So I got lots of instruments. If I can remember, and I always forget, maybe someone can remind me next time I post. Okay, here's the deal. You can comment on the live stream before it goes live. I'll post it a couple days in advance. If someone can remind me to do something with an Indian instrument, a silly song with an Indian instrument, I will do it. But otherwise I'll forget, because the ukulele is just so easy and it's just right there and I don't have to do anything. So please just remind me or send me a note. You can contact me directly through on Twitter or on LinkedIn or through my website, statquest.org. So there's that. So someone asked if I save my live streams, and the answer is yes. Not only do I save them, I post them. So if you miss them, it's not that big a deal. It'll be aired, last time I did it, I put it on my channel about a week later. Excuse me. Why did I say a week later? I posted it the same day, so like 4 hours later. I do a little bit of editing. What I do is if there's like weirdness at the beginning, I'll trim off the weirdness at the beginning, and if there's weirdness at the end where you see me like trying to turn everything off, I'll trim that off. And for some reason, making those small edits on YouTube takes about 3 hours to do. It's not that I spend 3 hours doing it. It's like it takes like 5 seconds to do the little trims of the beginning and the end. And then YouTube's like processing, and it processes for hours. I have no idea why it takes so long, but it does. So I try to get it out by the end of the day. Today, however, I've got a very busy day. I got a meeting I have to run to as soon as this is over. And then I've got to go grocery shopping, because yesterday I was preparing for this live stream. And I was like working like all day and all night, and I realized I have no food in the house, so I have to go get some food like as soon as possible. So that's part of the plan. But as soon as I can, I'll put this up and you can watch it. Someone asked if I can sing a song for you, and the answer is yes. But should I do it right now? I mean, we did have a silly song. But maybe I actually really like that song so much because it is Tuesday. And so I went, Tuesday, we're gonna learn about feature. Oh, I forgot it. Oh, man. it was actually one of my favorite songs. I was like, oh, I love this song, but it's gone now. Oh, I can't remember it. I'll have to go back and learn it. It was just like a killer song. The Tuesday was somewhat syncopated. I remember it, and I was like, oh, I love this. Um, I have to go back and remember that one. It's a good one. So what else we got here? Um, yeah, so singing a silly song was kind of a bust. Someone asked if I speak any other language other than English. And the answer is, unfortunately, no. That being said, I've attempted to learn Spanish, Portuguese, and Japanese, and maybe a little bit of French. Um, I've gone to Brazil. I believe I've been there twice. I've been to Rio twice. I've got some family that lives there. Um, and so I've been trying to learn Brazilian Portuguese so that I can go there and have more fun than I did without knowing Portuguese. Um, so where I live though, there's lots and lots of Spanish speakers, and so I've actually, when COVID hit, I think everyone picked up like a COVID hobby because you couldn't go out and do anything. And my COVID hobby, which I've continued to this day, is to practice Spanish. And I'd say I am like, it's as if I've taken like 3 semesters of Spanish. I can speak a little bit in past tense, a little bit. I went to Japan. So anyway, Spanish is I'm working on it. I have a dream of learning it. I'd love to learn Italian. Anyways, I traveled to Japan a few years ago before the pandemic, and so I learned some basic phrases in Japanese, and that was super fun. Being in Japan and saying little phrases like "so desu ne." It was just great, and I'd love to go back to Japan and learn more Japanese. Anyways, learning languages, I've discovered, is really fun. It's hard. It's one of those things where it's like, if I could do it all over again, I would have done it as a kid. When I grew up as a kid, we lived on a farm in the middle of basically nowhere. And so learning a foreign language was the most abstract thing ever. And when I was a kid, I didn't travel very much. But now that I'm an adult and I'm traveling, I'm like, oh man, I got to learn languages. So that's something that I'm kind of like loving. And what's cool, so along the lines of languages, is I think I can talk about this. I'm in a beta test program, and I can't actually remember the name of the company. But what they've been doing is they've been providing translations of my new videos. Not my old ones, unfortunately, but the new ones. The last 2 videos that have come out have had Spanish and Portuguese, Brazilian Portuguese, overdubs. And so the process is, I write out the script and I make sure it's all good, and then they convert it into these other languages and they provide overdubs. And so if you know Spanish, or Spanish is your number one language, or Portuguese, Brazilian Portuguese is your number one language, you can actually watch my new videos in those languages. So that's pretty cool. And what's super cool is I think they're going to start rolling out more and more languages. And so once I write the script, they can just like translate into all these languages. I know they've got Hindi as high on the list. Arabic is on the list. Turkish is on the list of things that might come out. I hope I'm not saying anything I'm not supposed to be saying, but I'm really excited about this. So that's something to look forward to, is more translations of my videos. So what else we got? Portuguese, triple bam, says somebody. John Lee says, sometimes we use multi-hot encoding if we want to encode a subset of possible values of a categorical variable. Can target encoding or similar methods still be applied? And the answer is, I believe so. I'm not an expert, but it seems reasonable, right? So yeah, I guess that's that. I mean, you've got a column with discrete values in it. You've got a target. Bam. That's all it is. Yeah, someone pointed out that these are not easy languages to learn, and that is very true. Um, English, by the way, the more I'm learning of Spanish and other languages, the more I realize how weird English is. English is like crazy. We have so many words that all sound the same and mean the exact difference, different things, like exact opposite. So, um, I mean, it's just like, how is that even possible? And spelling, like I'm learning Spanish, and spelling in Spanish is just so easy for me. I'm a terrible speller in English. I can't spell a thing in English because the spelling doesn't really match how the word sounds often. But in Spanish it does, and I'm like, yay, that's so cool. So I'm excited about that. But what else? Any other questions? Um, Someone says that my videos are helpful. That's really great to hear. Um, Someone says they're on their way to becoming a data scientist. That is exciting. Let me see. I'm going to scroll back. Someone asked about the book and when is it showing up in India? And the answer is hopefully by the end of the month. On Thursday, I'm doing a Zoom call with a printer in India. Um, this is the third sort of organization I've contacted about doing this in India. So, how optimistic am I that it's going to succeed? Not super optimistic, but there are other printers in India that I'm going to try to work with. And so we'll just see how this goes. On Thursday, we're going to have a discussion. Then what I need to do, so if it looks like it's going to work out, this is something I don't understand. I can sell my book for $20 a copy in the US. Getting it for that price in India is almost impossible. Everybody wants to charge more. They want to charge $25, $30. And it doesn't make sense to me that my book should cost more in India than it does in the US. Anyway, so that's sort of one of the sticking points is the price. I feel like if I print and sell a book that's really expensive in India, that's a disaster. So we're going to negotiate that, and we're going to see what we can do. Hopefully it'll work out. I would love it. The new sort of I don't know if you realized, you may or not realize, but my book was originally written as a landscape format, and I've reformatted it for portrait mode, which is easier for people to print, and so hopefully that'll help things in India. I'm also working on getting it printed in Australia. I'm going to work on that later today, and I'm also going to start working on it getting it printed in Brazil. So there's like three big sort of like StatQuest places that I've been having trouble getting my book to, and I'm really excited about the new version. Partly because I corrected a lot of little mistakes. Not, I say a lot. I've probably in the 304 pages. So far, people have reported to me 5 sort of typos where it's like, if you do the math, you get like a slightly different number, or like an arrow is pointing to the wrong thing. So there were 5 typos I've corrected, 5 typos, not, and a handful of like places where when I reread the sentence, I was like, there's a better way to write that sentence. And so I fixed those. So I'm excited about the new version. So that's the word for the book. Someone just asked if we should do exploratory data analysis with just the training data set, or we should do it with all of the data before splitting it into training and testing. So that is sort of a question about data leakage and sort of the things you're going to do, because because if you look at the whole data set, what will become your training, testing, possibly validation data set. If you look at it all at once, it's kind of like peeking at the end of the book to see how the mystery ends. Um, so yeah, you have to be very, very careful with that. So generally speaking, if you have a data set that's large enough, split it first. And that's actually reminds me, we'll talk about ways to then encode data that you might see labels that you've never seen before. How do you encode those? So we'll talk about that hopefully in a future live stream as something coming up. Someone asked, is it hard to make a living off of YouTube? I'd love to make videos myself, but I don't know if it's a feasible path for me. Love your videos. So here's the thing to say about that. Yes, it's very hard. And for a long time, I did not do it full time at all. I just did my job and I made my videos, and that was a great arrangement. And I was happy, to be honest, I was completely happy with that arrangement. So that's a great way to start. The other thing I want to say is it's important for you to understand what success means when you start doing something like YouTube. What does success mean? So for me, I created YouTube for a very specific reason, and that was to teach my coworkers, of which there were about 15 at the time. I used to work in a genetics lab. My goal was to teach my coworkers basic statistics. And the reason why I wanted to do that was they all did awesome genetics experiments, and they gave me their data, and they were like, work your magic on it. And to be honest, I love statistics. I love data science. I love these things. I'm passionate about them. And when I get passionate about something, I want to share it. It's like when you take a bite of something that's super delicious and you're like, oh my gosh, you got to try this. This is so good. That's the way I felt about statistics. It's like, oh my gosh, you guys, you got to understand how awesome this is. And so I wanted them to understand the basics of statistics just so I could share my passion with them. But also, I would, if I did the math and I gave them the p-value or whatever basic statistics we needed to do, I also wanted to feel confident that they would go, when they were not around me, they would still understand what those terms meant, and they would speak about them intelligently. Like if they go to a conference and someone goes, what's the p-value? Oh, by the way, shout out to Roy. Thank you very much. So anyways, I created these videos to teach my coworkers. So if you watch any of my early videos, you'll notice they're all about mice. And that's because I worked in a genetics lab that worked on mouse genetics. And so these videos were for my coworkers. And so when I started making videos in my first year, I had about 9 views, which a lot of people would go, that's a disaster. That's like the worst channel ever. But for me, that meant I was successful. And the reason being is my videos were created not for the whole world to watch, but for my coworkers. And to get 9 views meant my coworkers were watching my videos, and that's success. That was my whole goal. I even got like 2 subscribers, and that meant not only did some of my coworkers watch my videos, they wanted to see more. And so that was a huge success. So that's how I got started with YouTube. And then I did that for maybe 4 years, where I was kind of like working my job, but also creating videos for YouTube. And again, I was still just trying to teach my coworkers, and I was like, hooray, we're successful. It just so happened that other people started watching them, which was awesome. And it also happened that the lab I was working in was starting to shrink, and and my boss was like, Josh, you need to do more research. And I'm going to be honest, I don't actually like research very much. I like helping other people. I liked helping the people in the lab, but there weren't that many people to help anymore. And so the only way for me to earn my keep was to start doing my own research. And I was like, I don't really like research, but I do like making these videos. And my boss simply said, you need to do whatever you think is the most important thing for you to do. And I was thinking about it, and I loved my job. I had a great job, and I loved my coworkers. I loved hanging out with them. Going to work was fun. But if I stayed in that job, I would only be helping a handful of people. And I looked at my YouTube channel, and I said, and if I do YouTube full time, I have the opportunity to help a lot more people. And I think that's probably more important for me to do. And so that's why I jumped off the cliff. And when I jumped off the cliff, let me tell you, I was making, I did the math, and I was making less money than someone who bags groceries. So it was very scary to jump off the cliff because I was making very, very little money at the time. And so I kind of panicked and I freaked out. But I had some money saved up for my old job. And so what I did is I was like, oh my gosh, I got to make some money. So what I did is I started consulting. I started doing statistics consulting. But then I realized that if I do statistics consulting, I don't have time to work on my channel. So sure, I had enough money to buy groceries and pay my rent. But the whole point of quitting my old job was to do more StatQuest because I thought that was a more important thing for me to do. So I stopped doing consulting and I started working on, I made my study guides. I started doing webinars. I started doing things where I was like charging a little money for, and that has made it all work out. And the book that I created, which I'm trying to get sold everywhere, but the book really made it work. Where now I feel like, yeah, I'm pretty comfortable doing this YouTube thing. That being said, there's also some anxiety that like, there's something weird about being a YouTuber that I just always feel like, how can this last? This is going to go away. I'm always just nervous that like I'm going to wake up and YouTube's not going to exist anymore. Maybe it's because I just love doing it so much that I'm like, this is too good to be true. Too good to be true. And anyway, so I do have some anxiety that one day it'll just vanish. So that's why I'm like, thank goodness I've got the book in place and things are going well. Anyways, we've been at this for about an hour. So I'll just do a little silly song to say goodbye and we'll call it. And hopefully in 2 weeks, 2 weeks from today, at the same time, we can do another live stream and we can carry on with what we were just talking about. We can talk about how to avoid data leakage with target encoding because you're going to want to know how to do that. So thank you for watching my live stream today. Hooray! Thank you very much. And tune in next time, 2 weeks from now, for another live stream.